This is the second video of Unit 6 review for your exam. Number 8 is actually an exit ticket that we did in the past, and some of you have the homework of correcting that exit ticket this weekend as well. So here's a freebie for you. Alright, so here it says what polynomial remains after the greatest common factor is factored out. So after I read that, I see a huge polynomial here, and I need to factor out the GCF. So I need to find what that GCF is first. So when I do GCF, I have to look at the actual numbers, the coefficients themselves, and I also have to look at each variable to see what I can factor out. If the variable is in all three terms, that means that I can factor that variable out of all three terms. If it's not in all the terms, then we cannot factor it out. The y is also in all three terms, so I can factor some y's out. The z's are also in all three of them, so I can factor that out. So I'm going to take care of the number first, because that's the easiest thing. You've been doing GCF, greatest common factor of numbers, for several years. So between 20, 15, and 5, the greatest common factor would be 5. If you have trouble doing that, you can start by getting the prime factors of each and then see what they have in common. For example, 4 times 5 is 20, 3 times 5, and 5 times 7. Okay, this also has 2 and 2. Okay, now that I've prime factored all of them, I can match to see which prime factors match in all of them. Okay, so in this case, I see that all of them share that 5 and nothing else. That is the same. So then that means that 5 is my GCF. For some of you, it's obvious when you just see the numbers. For some of you, you might need to do prime factorization. Okay, so now we're back with the x's here. I have x to the 8th, x to the 5th, and x to the 3rd. So we're limited. The most we can take out would be the one that has the least. So here I can take 3 x's out, and so I can do that here too and that here too. If I say x to the 8th, then I cannot remove x's from here. I don't have enough. I don't have enough here either. If I say x to the 5th, then I don't have enough over here. Okay, if I say just 1x, if I factor 1x out of all of them, I still have a bunch of x's left over. Okay, so here the rule would be to see if every term has that variable, and then the one that has the least power, in this case x to the 3rd, that would be the one that would be factored out. So in this case, x to the 3rd. I'll do the same thing with the y's. The y's have y squared, and y to the 3rd. So the most I can take out would be y squared, because this one won't have enough for 3 y's, and this one either. Okay, and then for z, I have z squared, z, and z. So the most I can take out, these are the least powers, would be z. Okay, now I can do my remaining polynomial. This is what's left over after I have divided or factored out this GCF. You can do this several ways. Some of you, I've seen you do it just by saying, 5 times what gives me 20, it's 4, and then, subtracting the letters. You can do that, okay? You can also do it by the box method, where you just do the reverse. You start with the original. Should have made the box a little bit bigger. I apologize. Okay. So there's a box. This is the last piece. Ignore that line. And then my GCF would be out here. Okay? And then we have to try to find what goes here on the top. And that would be my remaining polynomial. Okay, so from here, I would do exactly like we do with reverse tabular, right? Either 20 divided by 5, or 5 times what gives me 20, in this case 4. The x's, I have 3 of them here, so x to the 3rd, and how many do I need in order to have x to the 8th? Or you can subtract them, right? 8 minus 3 would be 5. Because 5x to the 5th times x to the 3rd, right? When you multiply the same base, you add the exponent, so you get x to the 8th. For the y, I have y squared, so I have 2 of them, and I need 2 of them, so I'm done. I don't need to add any more here, or multiply it, right? Z, I already have the z, so I'm done with that one. Over here, you would do 5 times positive 3, x to the 3rd, but I need x to the 5th, so that means I need x squared here to make x to the 5th. I have y squared over here, and I need y squared, so I already have it. I'm done. I need a z, and this one already has a z, so I'm done. And the next one would be 5 times 7, that gives me 35. X to the 3rd, I already have x to the 3rd, so I don't need x's. Y squared, over here I have y to the 3rd, so I need one more y. Z, I already have z, and I need z, so done. So this would be the remaining polynomial. Okay? And my answer asks what polynomial remains. So remaining 4x to the 5th plus 3x squared plus 7y. Okay, that would be the answer. Now over here on the side, I'm going to tell you another way, and this is how the Springboard lesson had it. So you get your original. This is another way other than the box. And then every single term, you're going to divide it every single term, you're going to divide it by your GCF. This is another way you could also think about this. Okay, here is your 4, and then here you subtract, or you think, oh, I have 8 x's on the top and 3 on the bottom, so I'm going to cancel out 3 and have 5 remaining, or just subtract it, 8 minus 3. 2 minus 2, 0, and if you don't see an exponent, it's 1. 1 minus 1, 0, done. 15 divided by 5 is 3, done. 5 minus 3, because you are dividing, so you subtract the exponents. Y squared, that cancels out. Z, that cancels out. 35 divided by 5 is 7. X to the 3rd, x to the 3rd, that cancels out. 3 minus 2 is 1y, and the z's cancel out. So you can also do it this way instead of that way. Okay? Alright. This question gave some trouble to some of you today. And if we didn't get to cover it, please pay attention here. Alright, so this one is an area of a square. So they tell us immediately that this is a square. Okay, and then here's a polynomial. And then so what are the side measurements? Okay, so before the problems we did, they gave us like, this is the width, this is the area, what's the length? So I know you had to divide. Here they just give us a polynomial and they tell us it's a square. So we're going to have to factor it, okay, in order to know. So we have 4x squared minus 28x plus 49. Okay, over here I notice that this is a perfect square and that's a perfect square. So even if they hadn't told me this was in the shape of a square, by knowing that these two are perfect squares, I know this will look like a square where both sides are going to be equal. Okay, so I'm going to have two equal sides. Okay, so I know that we do the reverse here, tabular for factoring. So you would have, 4x squared, your first term, and then your constant. And And then you have to find the linear terms, and they need to add up to negative 28x. I know that we did AC that adds up to B, but AC here, 4 times 49, will give us a huge number. Okay? But because I know that these are perfect squares and this is in the shape of a square, I should know the formula, which is the one that we did in this section right here, but this one is the difference of squares, this one is the one that is the identical twins, right? So before we go into that, let's just think for a second before we figure this out, how this would play out if we were to actually draw the algebra tiles like we did in the past. So you have 4 of those, so I'll just put this on the side so I can help you think and then come back to what we were going to do. So you would put those together, right? The algebra tiles that we did in class, we have the x squares. And then comes the 49, right? So you have the little tiles that were, I think, blue. And then you have to put 49 of them. But you know that this has to be a square. Like, it needs to look like a square when you are done with putting all the little tiles here. Like, you have to have a perfect square where this side and that side is the same. So when you have 49 here, you know that you're going to do a 7 by 7, right? Because you need a square, 7 by 7. And then remember, it was super easy once you had that, like, oh yeah, then I can just put my x tiles, and I'm going to have 7 of them here. But then you say, wait a second, I have to have not just 7, but also there's a second row on top, right? Because I have another x squared on the top. So in reality, you're not going to end up with 7 of them, you're going to end up with 14 of them. And then on this side, you also will have 14 of them because you will have this one, and because there's another one here, that. Okay? So then how do you relate this 14 to the 28 here? Okay? I hope you see that 14 and 14 makes 28, and it's a perfect, like, half and half. Okay? Because we have to preserve that perfect square shape where this measurement is the same thing as this measurement. So, let's go back to this. Every time that this is a perfect square and the constant is a perfect square, okay, you're going to half this, okay, in half, and that's what's going to go over here. That's going to be your linear term. So negative 14x, negative 14x, because we want a negative number. Okay, and you don't have to do AC equal to B because this is a perfect square. Once you have that, then you do reverse tabular. Now, remember that when our leading coefficient is not 1, when it's a different number other than 1, our first step is always this top part. So the GCF of these two is the one that begins that process of reversing. So here the GCF would be 2x for these two. Okay, and then you continue. So if this is 2x, this must be 2x as well, which makes sense because they have to be the same. And this is going to have to be 2 times what gives me negative 14? Negative 7. And this must be the same because they are perfect squares. So the measurements, this is what are the side measurements of this square? We are 2x minus 7 by 2x minus 7. Or you can just say 2x minus 7 squared. Each is 2x minus 7 also. You can also say that. Right? Number 10, now we're factoring, just like we did here, but this one's a little bit different. If you notice, this is a 1 and this is an 18. Neither of those are perfect squares, so we know that our shape is going to be a rectangle. So in that case, if it's not a perfect square, we go back to our old ways. We put our box. Okay, this one goes here, the constant goes over here. We draw our t-chart, AC, okay, AC equals to 18, and B is 11, right, because it has to add up to 11x. Now I have to find factors of 18 that add up to 11, okay? So I can have 9 times 2, okay, and then test it out. 9 plus 2 does equal 11, so those factors work. Because here the leading coefficient is 1, I don't have to worry about where I put these or anything. They can be on either side. Okay, and then the ones out here would be the same. X by x, and then plus 9, because 9 times x, 9x, and this one plus 2, because x times 2 is 2x. And that would be your answer here for number 10. Okay, number 11 also gave you some trouble this today in class, because it's a pictorial representation of a subtraction. Okay, so I want to know like my original polynomial, and then I'm going to take away, and what did I take away? We go over here, right? The takeaway would be a minus sign, and then what did I take away? And then what was the answer? What was left over? Okay, after I took stuff away. So the original, first of all, I look at my picture, and then I see that these over here are circled, and I recognize them as 0 pairs. And because they're circled, I know that in class we practiced that, and I know that these are 0 pairs that you had to have brought in. So they were not original to the problem. So that means that since these were brought in, this is the original problem, including this one that is x'd out, because that was original. So I have 2x squared, and I have 7 of the negative x tiles. So 2x squared minus 7x. Okay? Then I took away. So I'm going to look at the x'd ones, the ones that are x'd out. That's what I actually took away. So what did I take away? I took away an x squared. And I took away 2 of the positive x tiles. Okay? When I took everything away, I had my answer, my leftover is anything that is not crossed out. So I have a 1x squared, and I have 7, 8, 9, don't forget these because you brought in the 0 pairs. So 9 of the negative x tiles. So 1x squared minus 9x. Okay? So this is what I'm looking for, this whole equation. Here I should have been more clear, and well, I do ask you for the subtraction, which is this, and then the answer, which is that. I should have said equation. This is the equation. Alright, so for number 12, we have this trinomial by this monomial. Because this is a monomial, this is going to be an easy division. So I can either do it where I write it in a box and I reverse it so that I can tell what the quotient is. Okay, the divisor out here, and then figure out my quotient here on the top. Okay, or, now put a little division. Or you can do it like the book where, this shared denominator is for all of them because there's pluses and minuses, so you can't break it up. You cannot cancel just one of them. This right here is the same thing as this. Okay? So you decide which way you like best. I'll do both right now. So in the reverse box, you would do 6 times y, right? So, or divide 12 by 6. 6 times 2 gives me 12. I have 1x and I need 3, so x squared. I have 1y and I need a y, so I don't need any on the top. 6 times what gives me 6? 6 times positive 1, because 1 times 6 is 6. I have an x and I need 3, so x squared. I have 1y, but I need 2, so I need 1 more y, so that y times y is y squared. 6 times negative 4 would give me negative 24. I have an x and I need an x, so I already have it, no x's up here. I have a y and I need 5 y's, so that means I need 4 more. And that's my answer up here. Okay? If you do it this way, you would do loss of exponents. So here I would divide this out. So that's 2 in the numbers. This is a 1 if I don't see it. 3 minus 1 is 2, and those y's cancel out. Okay? Over here, 6 and 6 cancel out, so that's a 1. This is a 1. 3 minus 1 is 2, and then this is a 1. 2 minus 1 is 1. So you use loss of exponents. So minus 4. The x's cancel out. This is a 1. 5 minus 1 is 4. Okay, so both ways right there. And the last problem is this. I have trinomial by trinomial. So that means I have a 3 by 1 box. Or a 1 by 3 box, sorry. 1 by 3 box. So it's a long, skinny box if it's trinomial by trinomial. Okay, my first step would be to write the denominator over here. Okay, and then the first term of the dividend right here. And now I have to find that first part here. So, right here, x squared times what would give me 3x squared? So, times 3 is 3 times x squared is 3x squared. Once I have this on the top, now I have to multiply out the remaining boxes. So, 3 times 3x would give me positive 9x. 3 times negative 4 would give me negative 12. Okay? So, I'm done with the trinomial I get. Now I have to compare. So here I got 9x, but I need negative 8x. So I need a remainder here. I'm going to have a floating box for the x terms. And that has to give me negative 8x. So if I have 9, I'm going to have negative 17x. Don't forget the x, because there are x terms, in order for me to get negative 8. Okay? Then I'm going to check the constant term, which is 12, and I need positive 15, so I don't have positive 15, so that means that I need another remainder box that would give me that positive 15 that I need. Okay, so that means that I'm going to have to add 27, and this is a constant, so just 27. Okay, so when you're done with that part, then your answer will have to be the 3, right? And then plus the remainder, which is negative 17x plus 27 over x squared plus 3x minus 4. Okay, remember it has to be a fraction when the denominator is the divisor. Okay? Here it's asking you for the remainder, so this is the remainder right here. You could also claim that all of this is the remainder, like if you represent it as a fraction. Okay? Alright, that concludes the review. Sorry for the length of the video, and good luck on your test.